In this video, I want to talk to you about some of the basic ideas of mathematics. The first basic idea is addition. All right, 5 plus 2 is 7. And then to undo addition, we had to use subtraction. So you take 7 minus 5 will get you 2, or 7 minus 2 will get you 5. So if you're undoing this problem, there's two different ways to kind of undo it. You can take away the 5 from the 7, or take away the 2 from the 7, and you'll get back to the other number. So we have addition, and then we have to undo addition with subtraction. And then with that, addition has this, doesn't matter the order, there's a certain property, but with subtraction, the order does matter. So the properties of each of these are slightly different, and that's an important idea. So let's look at multiplication and division. So with multiplication, all multiplication is adding the same number very quickly. That's all multiplication is. We're adding 2 plus 2 plus 2 plus 2 is 8, or we can speed it up by saying 2 4 times is 8. And we've thought of different ways to write multiply. We have the dot, we have parentheses, and there are other ways you can even do it, but those are the most common ways to write multiply, which is adding very quickly. And then from multiplication, we created division, which undoes multiplication. So if we have 8 divided by 4, because there are 4 sets, I get 2. So I have, again, the 8 divided by 4 pieces would be, each piece would be 2. Another way of writing this, you could have put 8 divided by 4 is 2. There's, again, also other notations. So division undoes multiplication, and multiplication is simply fast addition. And then with multiplication, again, just like addition, it doesn't matter the order at which you multiply. 2 times 4 or 4 times 2, they're the same. But when you divide, the order at which you're doing it matters. So there are properties that come up when you start doing certain operations. So next, we come up with powers, and their undoer is radicals. So, but powers is multiplying quickly. So 2 times 2 is 4, which means 2 times itself twice is 4. Or 2 times 2 times 2 is 8, which is 2 times itself 3 times is 8. So what we did is we created this power to speed up multiplication of the same number repeatedly. So again, we're kind of speeding up, creating a new notation, which is called a power. And then to undo powers, we have to think of an operation undo it, and we created the radical. So the square root of 4 is 2. They also write a square root as a 1/2 power. You might not know that, but a square root is a 1/2 power. And what that's doing is it's undoing. It's saying what times itself twice is 4. This is called a square root. Now technically there's a 2. You could write a 2 right here, because look down here. The cube root of 8 is saying what times itself 3 times gives you 8, and the answer is 2. It's backwards of doing this. And again, instead of doing the cube root, you could write it as the 1/3 power. And you could have radicals of a whole lot higher root, just like you could have powers of higher than a 2 or a 3. And then these things have their properties. Actually, there's crazy amounts of properties for powers, and radicals all have their own properties that you can learn. The first 3 things we talked about were operations. Now we're going to talk about exponents and logarithms. Exponents, 2 to the 3rd is 8. Logarithms undo exponents. This doesn't make a lot of sense. We're not going to talk about how we get them and stuff exactly, but this notation undoes this notation. Meaning, if I say 2 to the what power is 8, that's an exponential equation, and I want to find out what's x going to be. Well, you can look up here and see it's 3. But this logarithm is how we write this in a logarithmic form, and you can find out what x is by knowing what this means. This is saying 2 to the what power is 8. That's what it says, 2 to the what power is 8. It's a really dumb, in my opinion, notation, but it's a notation mathematicians decided upon, and we kind of got to go with it. So exponents are like this. X to the what power is 12. If we wanted to find x, we would undo it by taking the cube root of both sides. Well, to solve this one, 3 to the what power is 12. To do this one, we would have to write it as a log, which it would be log base 3, 12. And that would be used to undo an exponential equation. And this one, to undo a cubic, you cube root it. You're using its inverse operation or inverse idea to undo. So now let's talk about trig. Sine of 30 degrees is 1/2 or 0.5. So if I want to undo this, I would write it as the inverse sine of 0.5 equals 30 degrees. This undoes this. Let me show you an example. I say sine of what angle is 1/2? Well, we can tell by looking at this is 30 degrees. But if we write it as an inverse statement, we would use the inverse sine of 0.5 is x. So if we could find this, we would know the answer of what's inside it here, which would be in 30 because you can see it right there. And so the inverse allows us to undo a function, an equation. So they can also call inverse sine as the arc sine. There's a whole bunch of notations for that. So here's how it's useful again. Cosine of what angle equals 0? From 0 degrees to 180 degrees. Well, if we wanted to find x, what angle would make this happen? What you would do is you would take the inverse cosine of 0, and then they have calculator, would be in the calculator. You do that, and you could find the angle for that on this interval. Lastly, let me talk about calculus. Calculus has something called the derivative, and what undoes the derivative is the integral. These are notations for something called the derivative, and these are notations for something called the integral. The derivative is finding the instantaneous slope at any point on a function. And so the integral undoes that and has its own fun properties. So in summary, what we're talking about here is that math is full of basic ideas and addition, and we undo that with subtraction. We multiply, which is quick addition, and we undo that with division. We have powers, and we undo that with radicals. We have exponents, and we undo those with logarithms. When it comes to trigonometry, we do trig, and we undo it with inverse trig. And we have the derivative when it comes to calculus, and we undo that with something called the integral.